Hey kids, it's me again. I'm sorry that I'm not here. My daughter got sick last night, and I had to stay home and watch her. So class still goes on. You should have your notes in front of you. And today, what we're going to do is we're going to learn about absolute value functions. And the one nice thing is absolute value functions are almost identical to the square root function that we learned 2 days ago, the cube root function, which we learned yesterday, and really it's just like the vertex form of the quadratic that we learned all last chapter. So again, today it's just kind of seeing what an absolute value function looks like, remembering what the a value, the h value, and the k value, because they all work the same. They do the same thing. It's just they're working with a different looking function. So let's get started. So this right here, up at the top, this is the parent function. This is what the absolute value function looks like right here. So f of x equals a, and then these lines, these vertical lines here, that's absolute value. That's what absolute value is. So it's not a 1. They're not really parentheses. They're just like big, long lines, and they're your absolute values. Now, your a value right here, so this tells you if it opens up or down, all right, and it also, as we worked with, stretches it. Your h value, okay, so your h value, again, moves left or right, but it's the opposite. Okay, so it's the opposite, and I'm writing with my mouse, so that's why it looks amazing. So it's the opposite of going left and right. And then the k value, again, that number on the outside, that's what goes up or down, all right, and it's exactly what it says. So if it says plus 3, it means up 3. If it means minus 8, it means down 8. Okay, so it's the exact value. So what we're going to do is we're going to graph the absolute value function in our graphing calculator, and what values we're going to look at are going to be -2, -1, 0, 1, 2. You can look at any of them, but these are the good ones to look at. Now, if you remember what the absolute value function does, what it basically does is it takes any number and says the distance that that number is from 0. So if we're to put -2 into the absolute value function, so how far away is -2 from 0? It's 2. How far is -1 away from 0? It's 1. How far away is 0 from 0? 1. How far away is 1 from 0? 1. How far away is 2 from 0? 2. Right? Or if you want to think about an absolute value function, just turn any number that's negative positive, and any positive number just stays positive. Now, if you're like, I don't believe you, Mr. Qualman, I need to see my calculator. All right, well, take out your calculator. All right, so I have a kind of new looking calculator. Ooh, ah. All right, and we're going to put this in our graphing calculator. Now, all right, I'm going to slide this over here. If you look up in the top right here, it says, do you graph absolute value? Look, I put the notes on there. Yay. So you can see exactly what to do. All right, new calculator, old calculator, you're going to do the same thing. So we're going to go to y equals, and we're going to put the absolute value of x in there. So what you have to do is you got to go math. Again, remember math, that's how you get your cube root. And you're going to go all the way to the right. You see this num, N-U-M? So there's the cube root that we did yesterday. We got to go to the right, num, and the first one, ABS, that's not abs, it's absolute value. So that means absolute value. Now, if you have an old school calculator, you will see ABS with a parenthesis. It works the same as the cube root, the square root, all those. If you have a new school calculator, you'll actually see 2 vertical lines with a flashing, blinky, dotted square. That's the cool part about the new calculator, is that you can actually see that. But whatever. All right, I'm going to put x in here, close my parenthesis as we talked about yesterday, and I'm going to go second table, and holy cow, look at these values. All right, look, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. All right, now, I think one of the coolest parts about this is seeing what this function looks like. So usually we don't look at this, but I want you to click graph and see what this thing looks like. Holy cow. Now, some of you are looking at it, and you might be thinking one of two things. Did I graph a parabola? No. Did I graph 2 lines? No. This is an absolute value function. It's kind of like the hybrid. It's like the combination of linear and parabolas at the same time. But it's not. Absolute value is really, the shape that it makes is a V. It's going to make a V. So if we were to graph this from the points that we have here, all right, this is what it's going to look like. So -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. You can see it's already kind of got that look of a V. All right, I'm going to make it over here. And again, yours is going to look a lot nicer. All right, but I want us to take a look at this point right here, the 0, 0. All right, if you look at it, what are you thinking that this point is? And if you said critical point, you're right. This is your critical point. C-R-I-T-I-C-A-L point. All right, this is the point that we care about. As we've been doing these past 2 days, all right, we care about the critical point and where it's moving. Is it shifting left, right, up, down? Is it reflecting? Is it flipping? Is it stretching? What's happening here? So that critical point right here, 0, 0, that's the big guy. All right, in the parent function, it starts at the origin, 0, 0. Like the absolute, like the square root function, and your square root function starts at 0, 0 and goes to the right. And just like your cube root function, which goes up and to the right and down and to the left, all right? So they all kind of start at 0, 0, the parent functions. It's pretty sweet, all right? Now, domain. The domain, or the x values here, if you look, it goes all the way to the left, and it goes all the way to the right. So the domain is negative infinity to positive infinity, all right? The range, now this is going to be the different guy. Now look, the critical point, the lowest point is at 0. The highest point goes to positive infinity. So boom. So it's 0 to positive infinity. Now, increasing, decreasing. Unlike the last 2 days, increasing, decreasing, you will have this happen. Both of them will happen. Because if you look, this is very similar to a parabola. From left to right, we're reading. The first thing that our graph is doing is actually going downwards. So it's decreasing. So it's decreasing from negative infinity all the way to your critical point of 0. And again, we're going to put our parenthesis. And then it increases from 0 to positive infinity. Perfect. And again, increasing, decreasing, you always use parentheses. You cannot use brackets because at 0, at a critical point, it's neither increasing nor decreasing. It's stopped. So you got to remember that. So today with absolute value, you will have both increasing and decreasing, unlike the last 2 days. So here we go. Now, just like yesterday, all right, kids are like, are we going to have to do this without a calculator? Yes, all right. You're going to have to do most of this without a calculator, like shifting left, right, up, down, reflected, stretch, domain, range. You should be able to do almost all this without a calculator, all right? Maybe getting your points down, probably not, but you should be able to get the critical point, which will tell you everything. So let's get started. So shifting left or right. So when we look at that, we're looking at the value on the inside, and this says +3. Again, on the inside, it's the opposite, so that means left 3. So we're going left 3 or left 3, all right? Shift it up or down. We look at the outside number. This is -2, so that means we're going down 2. Now, what I do, don't worry about reflected and stretch. Let's go down to the critical point, and let's put that in. Since we're going left 3, down 2, that means our critical point is -3, or sorry, yep, -3, -2, all right? Now, reflected or stretched, your A value, if you look here, your A value, you don't see one, it's 1. So no, NO, and stretched, NO, because it's 1. So there's nothing there. Now, what I'm going to do is I'm going to draw a little mock graph. Notice there's no graph here. There's no graph. So what I'm going to do is I'm going to put a little mock graph here, bam, bam, all right? And I'm going to plot the critical point. So it's left 3, 1, 2, 3, down 2, 1, 2, bam, there's my critical point at -3. Now, it didn't get reflected, it didn't get stretched, so it's going to continue to open up to the right and up to the left. So drawing this little mock graph is going to help us out for domain, range, increasing, decreasing. So domain, the one cool thing, just like a parabola, because it's going to the left and because it's going to the right, it will always be negative infinity to positive infinity. All right. Your range, again, find your critical point. The lowest part that your critical point is at -2. So my range is -2, and it goes all the way up to positive infinity. All right, now, increasing, decreasing. So start from the left of your absolute value. And our absolute value from left to right, it's decreasing first. So it's decreasing from negative infinity, all right, negative infinity, all the way. Now, decreasing, increasing is to what x value? And it's decreasing all the way to -3. So it's decreasing from negative infinity to -3, parenthesis, because you can't equal -3, and then it begins to increase from -3 to positive infinity. Now, we've done plenty of these online notes, all right? If I'm going too fast, pause. If I'm going too slow, speed up or keep writing, okay? So let's go to number 2 now. Number 1's done. Number 2, so let's look. Shift left or right. Let's look inside. I see +5, so that doesn't mean right 5, that means left 5. So I'm going left 5, all right? And am I going up or down? If we look, there's no value here. So that means we're going nowhere. Shift it up or down? No. So 0. We're not going anywhere. So I go automatically right down here to my critical point, which is going to be -5, 0. It's not shifted up or down. All right. Now, let's look at the reflected stretched, right? My value is 4. Now, 4, because it's still positive, is it reflected? No. That means it's not going to be flipped. All right, it's not flipped, but it is stretched. Yes, it's going to be stretched. You're going to see that it's actually going to kind of stretch, almost like kind of invert itself, like scrunch itself upward. All right, and actually, I'll have you put this in your calculator so you can see it. Now, domain range increasing, decreasing. Let's do a little mock diagram. Let's see what this thing looks like. All right, so our critical point is -5, 0. So we go, bam, right here. This is -5. We'll just make that -5 right there. And whoop, sorry, because it's not reflected, it's still going to open up to the right and up to the left. Now, again, how the V looks, whether it's really out wide or scrunched up narrow, doesn't really matter for domain range, but we will look at that shortly. So, domain, sweet. It's absolute value, so it's -infinity to positive infinity because it goes all the way left, all the way right. Our range, because we're still on the x-axis, it didn't get shifted up or down. Our range is from 0, always start at your lowest, to positive infinity. All right, positive infinity. Increasing, decreasing. So I'm going to put my little right here on my x. So from left to right, I'm decreasing to -5. All right, so I'm decreasing, decreasing -infinity to -5. Always looking at your x values, -5. And then from -5 to positive infinity, you're increasing. Notice how I always do that. For the last two, I always start from left to right. They may not be in order, but it just kind of helps you think through these problems, right? Now, let's just sneak a peek at what that 4 actually did to this problem, okay? So if I go back to my calculator, I turn it on, go to y equals. Now check this out. We're going to leave this ABS x in there. If you erased it, put it back in there. If you didn't, go down to number 2. Now what we're going to do is we're going to put this in 4, absolute value of x plus 5. Just watch this. So we're going to go 4. Now we got to get absolute value. So you go back to math, go over to number, and you hit enter at ABS. And now we're going to go x plus 5, and please close your parenthesis. You need to do that. Now, we want to look at the graph. So we're going to have 2 graphs on there. The first graph you see is going to be the parent function, and the next graph you see is going to be, well, this new function. Let's see what happens. Ready? So there's your parent function. Holy cow, look at that. Now, if you notice, this kind of like scrunched upward. It kind of shrunk inward. What you're going to realize is that that stretching is actually going to pull your value in or push your value outward, all right, your graph. So here, that 4 kind of shrinks it upward. It pulls that thing upward, all right? And we're going to talk about that next week, about really what that A value is doing and how we can find it and what it's actually going to look like. But there you go, all right? With an A value of 4, notice how it kind of pulls that thing inward. Some of you are probably starting to think, I think I might know what it does. That's awesome. You're very bright, all right? For the rest of you, if you're like, I don't know yet, don't worry, all right? You're fine. All right, so here we go. Last 2, compare the functions. Now, this is an important thing, being able to compare. So I'm going to compare using 2 different colors. So I'm going to put this, y equals absolute value of x. That's your parent function. And then y equals -2 absolute value of x plus 6. I'm going to put that in blue. So we're going to compare these 2. All right, we're going to compare them on the same grid, compare their domains, range, critical points, increasing, decreasing, basically everything. And really just seeing what's actually happening here. So when we compare, we have to compare using the same values. So I'm going to use those same values from before. because we already have them. -2, -1, 0. Oop, I don't know why I put -0. It doesn't matter. It's neither negative or positive. So 0, 1, and 2. I'm going to put the same values over here, but I'll put them in blue. Kind of keep the same color thing. -2, -1, 0, 1, 2. Now, these values for y, I can actually snag from up here. 2, 1, 0, 1, 2. I'm just going to steal them. Don't have to really do anything. We already did the work. So 2, 1, 0, 1, 2. And what I'm going to do is I'm actually just going to plot this one first. So -2, 2, boom, -1, 1, 0, 0, 1, 1, 2, 2. And as best as I can with my mouse, oh boy, that looks awesome, doesn't it? All right, I'm going to make my absolute value. Now, if you have colored pens or pencils, this would be really cool to do in different colors. If you don't, well, maybe make one really dark and one really light with pencil. So that's your parent function. So let's see what -2 absolute value of x plus 6 does. Now, some of you might be saying, Mr. Quammen, I realize that that a value is -2. Something's going to happen here. Well, we're going to see what happens using our calculator, right? So we're going to go, let's clear these out. Let's clear both of them out. And let's put this in. So we're going to go -2 absolute value. So we go math, go over to number, go down, well, abs is the first one. So absolute value, we're going to put x, close your parenthesis because that's the only thing that's getting absolute valued, and then plus 6. So you want to see what it looks like first? All right, let's see what it looks like. Holy cow, look at that. Now, some of you might have been saying, Mr. Quammen, I knew that was going to happen because that -2, the a is negative, so it's going to flip it, just like a parabola. All right, negative people frown. It's very similar to a parabola. All right, so it's going to go upside down. So let's actually look at what the table values are for -2, -1, 0, 1. So -2 is 2, -1 is 4, 6, 4, and 2. So I'm going to put those down. So -2 is 2. Oh, let me put that. Where's my color so we don't get confused? -2, -1 is 4, 0 is 6, 4, and 2. Now, if you look, all right, we should be able to tell from here, without even looking at this, what our critical point is. What our critical point is. So for our blue guy, our critical point, we're not moving left or right, so it's 0, but it's plus 6. So our critical point for the blue guy is 0, 6. For our red guy, which we already have plotted, our critical point is 0, 0. Now, to compare, what's the difference between these two critical points? Well, the blue with the negative is shifted upward 6. So let's actually plot these. Let's plot the blue right now. All right, let's plot the blue. So -2, 2, -2, 2, -1, 4. Is that 4? No, this is 4. -6, 0, 1, 4, and 2, 2. If you look at this, ooh, okay, no, a little ugly, but whatever. Again, it's using a mouse. All right, there's our graph. So we can look at this and say, hey, all right, I can compare already. The parent function opens up, the blue function opens down. It looks like the parent function is opened up wider than the blue function, or the blue function is kind of skinnier, narrower. It looks like it's stretched more. These are verbal observations, but we can also compare their domains and range. Now, if you look, for both the red and the blue function, they both go outward left and right. So believe it or not, their domains are going to be the same. -infinity to +infinity. So that's for the red. Oh, make sure you put your parenthesis there. And then the blue guy is -infinity. Oh my gosh, mouse is freaking out. To +infinity. And again, this slash is just to kind of divide the two. But they both have the same parent, or both have the same domain. So regardless if you move it, stretch it, flip it, do whatever, your domains will always stay the same. But your ranges, well, those are going to change. So the range, your y values, you go from lowest. So in the red, it's from 0 to +infinity. So you can put a bracket because you can equal 0 for your range to +infinity. Put your parenthesis. And now the blue function, now here's the fun part, and this is what kids kind of mess up, so pay attention. When you do range, when you do domain, when you do increasing, decreasing, you always go from lowest to highest. All right, so because it's flipped downward, you are going from negative infinity all the way down here, negative infinity all the way up to 6. So your range is negative infinity all the way to 6. Come on, buddy. There we go. And you're going to bracket that because you can equal it. So your range is different here because you're actually going to get the negative values all the way up to 6, whereas in the parent function, you start at 0 and go all the way up to positive infinity. So this is what we're doing. We're really comparing. We're just comparing and writing down the different values for these. Now, increasing, decreasing. Now, if you notice, both of these guys their critical points are on the y-axis. Oh, God, that looks terrible. All right, let's see if I can do this. Let me get a line value. Let's get this. All right, let's see if I can do this. Whoosh, look at that. I still screwed that up. Anyway, I'm trying to just make this a little obvious for you. Really? Really? You're not going to let me? Okay, whatever. Here we go. So by putting this on here, it should help us determine what's increasing, decreasing. So let's start with increasing. So for the red function, we're actually going to go decreasing first, because if you look, remember, we always want to go from left to right. We're actually going to decrease in the red function from negative infinity all the way, and again, I got this dashed line, we're going to decrease all the way from negative infinity to bam, to 0. All right, it's always your x values. All right, parenthesis. Now, we're going to increase from 0 to positive infinity. So now I'm going to increase, oh geez, from 0 to positive infinity. So I'm going to put increasing, decreasing right next to each other. All right, and I'm going to put like a little squiggle line for increasing, decreasing. So the red increases from 0 to positive infinity. The red decreases from negative infinity to 0. Now, the blue, check this out. So again, look from left to right. The blue, because it's flipped, it's actually increasing first. So I'm going to go increasing from negative infinity all the way to 0, negative infinity all the way to 0, because that's what it's doing, from negative infinity to 0, which is here. You're caring about the x value, not the y value. It's increasing, and then from 0, this blue guy is decreasing. So from 0 to positive infinity, it's decreasing. Check that out. So if you look, they kind of like flip-flopped their increasing, decreasing. I wonder why that happened. It's because of the a value. Because of that flipping, your increasing, decreasing flip as well. So that's your notes. Hopefully this makes sense. If it doesn't, well, you get to watch it a million times. Otherwise, I will be back on Thursday. We'll continue working. I think we're going to do another day of absolute value and kind of really tie a lot of them together. Again, the big thing is for you to be able to look at a function and determine, does it move left, right, up, down, flip, stretch, what's it doing? You should be able to do all of that without a calculator. Now, graphing, getting points, calculator is perfectly fine. I'm cool with that. But you should be able to do all those things without a calculator, okay? I'm sorry if any of you came in to get some help this morning. You know, it was a freak thing. She had a fever, so we couldn't take her to daycare. I'm sorry. I'll be back. Please come on in early tomorrow morning if you need any help. Otherwise, go get your homework now, start working on it. Hopefully you have nothing to do tonight so you can watch the Cubs even up the World Series. All right, guys? Have a great day. Be good to the sub.